Hello, Professor. Hello, everyone. Yeah, myself Shrikant. Yeah, my team members are Jyoti and Mansa. Today, I am discussing about comparative analysis of search algorithms. Yeah, yeah. Coming to introduction, artificial intelligence is a study of how to make a computer to think like a human. It has sub areas like machine learning and deep learning. Artificial intelligence. Nowadays, artificial intelligence is used in many ways. In search algorithms are available to the problem of shortest path to find the paper presentations to detailed study of the information. It is a relationship with other fields. It's artificial intelligence and machine learning and deep learning and data science. Uh, it is artificial intelligence combined with these four topics. Uh, Coming to the searching techniques, it includes in problem solving, knowledge and reasoning. There are two problem solving techniques in artificial intelligence. There is a uniform search and informed search. It is a uniform search is a type of blind or brute force search that uses strategies includes BFS. BFS is a breadth first search, and DFS is a depth first search, and another one uniform cost search, and iterative depending and bidirectional search. This a informed search is a research search is a type of problem solving technique that uses a heuristic functions to assess how close to given state is to the goal state. The generate the method is used to inform search hill climbing, steepest hill climbing, and AAO and best first search algorithms are among the algorithms included. And coming to work for search techniques, it's a BFS is a economy that stands for breadth first search. All nodes are extended one level at a time in breadth first search. It is expands all nodes in the first level of search tree initially. In the tree diagram, it is first level of search is initial. All nodes in the second level, and so on until it research the target. Yeah, it's comes in this diagram shows it is an open list and closed list. In this T diagram, in open list and closed list is almost first one is same, and second path is 2 and 3 are 4. In this 2 and 3 is 4 is a closer path is 2, and 3 4 6 in this 3 4 6 is a closed path is a 3, and 4 6 5 is a closed path is 4, and 6 5 7 closed path is 6, and 5 7 is a closed path is a 5. Is finally goal state is a 8. Is a no closed state is there in goal state. It is open. Yeah. And DFS, depth first search. In a search for the goal node, depth first search expands from the source node to the deepest unexpanded node. The forten is actualized as a stack in depth first search, and it acts as a last in first out. LIFO. It is also known as a recursive algorithm because it is used to the stack to implement it. The complexity of time and spaces is where B is the branching factor and M is the greatest depth. And DFS is also same like open end and close end DFSs, open list and closed list. In this table, it's open list is 1, and second one is a 4 3, it's closed list is 2, and 4 3 6 in this T diagram in this path is 4 3 6. 4 3 6 is the 6 is the closed path, and 4 3 is the closed path is 3. 4 coming to 4 to 5 is a closed path is 5. 4 to 7 is closed path is 7, and 4 and 8 is a goal state, and there is a no closed path. UCS, uniform cost search. Uniform cost search expands the node with low cost path. It is implemented using the priority queue. Uh, to calculate cost of every node, consider this equation: C of m equals C of n plus C of n comma m, where C of m is the cost of the current node, C of n is the cost of the previous node, and C of n on m is the weight of the edge. And A star, to compute an optional solution, the A star algorithm combines the benefits of uniform cost search and pure heuristic search. For computing cost of every node, consider this equation: f of m equals C of m plus h of m, where C of m is equal to C of n plus C of n comma m, and h of m is a historic function. F of m compute the most reduced aggregate cost in this slide. Can Yeah, A star in this diagram, in this T diagram, it is a open list and closed list. It is a one and one open list, and closed list is the one, and two and five is closed list is two, and five and three six. This path is closed path is six. 5 comma 3, this closed path is 5, and 3 7 10 in this path, closed path is 10, and goal state is a last 3 7 9 12. This is the goal state. And next slide, please. Yeah, best first search, the most effective best first search. As the term best first search refers to a combination of the terms breadth first search and depth first search. Is the priority queue is used to implement the best first search. The benefit of the depth first search is the it provides a solution without having a calculation of the nodes, while breadth first search is arrives to a solution without searching the techniques. As should not be catch be best first search is a being combination of two allow licenses to be exchanges between pathways at a search appropriate is chosen similar level, so you can choose the depth first search and best search. Yeah, next topic, Jyoti will continue.
Yes. Hello guys, my topic is server weather avoidance using informed heterostate search. The security of aircraft is endangered by the harsh climate. In this report, an algorithm for general um, aviation aircraft is created that takes a satellite picture of the thunderstorm as data and the calculates the shortest course around with the least amount of departure. The efficient algorithm is made up of the real route and the judgment algorithm that calculates the remainder routes estimated price. And the coming to the introduction, because an aircraft major operating environment is indeed the environment, and the environment activities play a significant role in navigating as well as the guiding. Introduction of the data idea of free flights, the necessary for a quick and safe climate avoidance algorithm has become even more urgent. And free flights is the novel air traffic management systems. A-star search is the another strategy that may be utilized to solve weather problems. And in the presence of the thunderstorm, A-star search is to discover the best way through the one spot to next. Climate was recognized as a contributing factor in 21.75% of all general aviation incidents in 1990s. In the same year, climate plays a role in 25.9% fatal incidents in the general aviation. And following these numbers, the importance of knowing weather events and their consequences does not appear to be overdone. with the introduction of the data of first flight, the necessary of the quick and safe climate avoidance algorithm has become even more urgent. In recent years, this area has gathered attention of lot of researchers. The microburst related accident at Dallas Fort Worth Airport in 1985 promoted the development of guidance strategies in an event of microburst encounter. The fastest route algorithm created by Digikstar is utilized in one of the early attempts to establish a basic system for guiding an airplane across weather affected airspaces. And the two components heuristic function has been designed for this purpose. The first component researches the cost of the traveling from the starting location to the place in question, which the second component researches the anti-created cost of traveling from this point to the destination. And then next topic is weather information. Server weather refers to any environment event that cause significant damage. This weather word is commonly used to describe isolated storms. Some events have potential to severely harm the an aircraft. These events are large crisis areas of several wind shears, violent updrafts and downdrafts, and tolerate downpours corresponding these environment conditions. And violent upgrades or downgrades can usually a significant change in the attitude of the aeroplane and can make the pilot lost control over the aeroplane. So these weather conditions should be avoided. Radar reflection, wind speed and direction, ice security, temperature, all the data that the pilot needed in general. However, for the purpose of this study, radar data is employed to identify thunderstorm strength. And generally, the pilot needs some data that radar reflection. Uh, Coming to the next topic, it's A-star search. A-star searching is the uh, heuristic search approach that the guided. Its goal is to reduce the overall route cost F. F of n is g of n plus h of n. N is the nodes, and g of n means the real cost of traveling to the node, and h of n is the cost of the getting from the node. And it also called as the heuristic function. It can be provided that the search strategy is full and optimum if the heuristic function selected for A star search is acceptable. A star search advantage is if one problem is solved, solution is existed, it can give more best and complete solution, but it takes the more time and the memory. Okay. Next is the development the weather avoiding algorithm constraints. The weather avoiding algorithm selected a flight path should be addition to becoming the quickest and avoiding extreme storms be within the some limits given by the comfort level, pilot effect, and the airplane's physical issues. All of the three limits should be addressed by the weather avoiding algorithm or either construction of the heuristic function or by limiting the maximum number of nodes that may be generated. Uh, okay. Next topic is identifying constructions. These we have three identifying constructions. These are minimum segment length and maximum turning angle and minimum number of turns. Minimum segment length means any two verticals in the flight route should have range between them which is higher or equal to the specified lower limit, and this lessen the pilot effect as well as the before beginning another turn the aircraft should be able to finish one. And maximum turning angle, the direction shift in a usual flight route is less than 600, but any event they must not execute the 900. Our technique impose this limited by restriction the number of nodes that may be created from the single node. And the last one is minimum number of turns. The produced flight route should be piecewise linear and contains a few twists as fitable, and it lessen the flight burden. And next we'll continue the Mansa.
Hello, Professor. My topic is about the thunderstorm avoidance algorithm. So in this, the distance between the two consecutive nodes is determined basically by a grid size. So here, the two limits within the node can be chosen by the extent of the inaccessible region and chosen maximum turning angle. So before beginning the search, the length L of the inaccessible region is determined depending upon the chosen minimum segment length and the number of turns that are allowed in the flight path. The segment I is divided into k segments. So in this case, when the grid size of the map is bigger than the of the radar image, the intensity of the each grid in the map is sent to the maximum intensity found in the area of the grid. The region within the intensity is greater than 25 dBs in the map is set as inaccessible. This algorithm basically assumes that the thunderstorm line ahead of the airplane is the flight path and neither of the 2 points, the starting point and the end point, lies in the inaccessible region. So, yeah. And if the starting point and the end point are not in the thunderstorm, then the root node is in the search tree is the starting point and the terminal node is the end point. So lastly, the number of nodes that can be generated at each stage are limited. So next is the heuristic function that is developed. So heuristic function is basically a straight line from distance from point to an endpoint. If the thunderstorm lies on the path, then there's a slight deviation is also added to the straight line distance. The actual cost of the path is traveled to reach the node. If there's a thunderstorm between a node and its a parent node, then the cost of the path is set to very high, such as a heuristic function gives a better estimate of the distance between the given point and the end point than just a straight line distance. In order to take care of these requirements, modifications are made to the search algorithm, and these changes are made along to the line segments of the simplified memory bounded algorithm. So one of the biggest advantage of the simplified memory bounded is that if the allocated memory is less than one required for the optimal path to the goal node, then this search strategy would either be a sub-optimal solution or in the worst case, it would have been a solution at all. So coming to the results, so we basically have 11 figures in it. So firstly, I will be explaining about the 4, 5, 6, 7 figures. So the starting and the end point can be seen and the thunderstorm lies in the flight path. Using the definitions above, the inaccessible region is determined in the radar image. The starting point is a point 1 and the end point is a point 2. After tracing the inaccessible region using the above algorithm, the shortest flight path between 1 and 2 avoids the thunderstorm that is obtained. Coming to the figure 6, the flight path with respect to the inaccessible region, and the figure 7 is the flight path with the radar image. The minimum segment length in this case is 8 units of the radar image. And coming to the 7th, 8th, 9th, 10th, and 11th, so here the original flight path from the point 1 to the point 2 goes through the thunderstorm as shown in the figure above. So the detour shown is the flight path directed by the weather avoidance algorithm. So whereas coming to the 10th and 11th, it shows the result of the simulation for the cases 4 and 5 respectively. For the sake of the clarity, the radar image is presented as a contoured plot and the grids are not shown. This area enclosed by the red contour has an intensity greater than 30 dBs and it is also enclosed by the gray contour. So in case of 4, a line of 3 thunderstorm is moving in the positive x direction at a speed of 40 miles per hour. This airplane is moving from point 1 to point 2 at a constant speed of 150 knots. In the case 5, a line of thunderstorm is heading in the negative x direction at a speed of 50 miles. So it can be seen that in all these three cases, the algorithm computes the safe and the shortest path between the 2 points, and the amount of time it is taking is reasonable. At the same time, the individual segment lengths in these cases are less minimum. The segment length specified for each of these cases shows that the results of the cases of 4 and 5 demonstrate the effectiveness of the algorithm in event of moving thunderstorm. Next is the algorithm convergence and the stability. So here, this algorithm always tries to find the solution in a forward direction where the event of being flayed by the thunderstorm along with the forward heading directions, this algorithm cannot retrace the path to get away with the thunderstorm. The algorithm also fails to compute the safe detours if the starting point of the path lies inside the region of these intense thunderstorm activity. So there's also another way to avoid the coming very close to the yellow and the red regions on the radar image. which is by specifying the minimum distance that should be separate the inaccessible region and the node closest to the boundary. With the capability, it will give better results and also provide the great flexibility in choosing the turning points in the flight path. So this algorithm also tells if the image on the small area on the map, but its functionality in the large areas are still needed to be established. So given the minimum segment length and the minimum number of terms, the algorithm succeeds in finding the solution. Coming to the summary and the conclusions. So basically here the results show the algorithm successfully computes the safest and the shortest paths in the small area of the map. It also uses the principle of A star and the suitable modifications along with the line of the simplified modified area search technique to reduce the time and the space requirements. The algorithm is applied to 5 cases of the thunderstorm and the simulation results are presented for the moving thunderstorms. The search tree has a finite depth and the depth has determined the number of turns along the path and the simulation results are encouraged, where the better results can be ensured by the turning point of the algorithm. So that is my presentation, Professor. Have a good day. Thank you.
Thank you.
Thank you.